Good morning, everyone, and welcome to our third week of our webinar series, Rutronik Connects. Rutronik Connect is a webinar series in which we talk about different technologies. We had Wi-Fi at the first week, cellular technologies in the second week, and currently we are speaking about ultra-wideband, LoRa, and other suitable technologies. Today, here with me, we have Murata. So we will explore a little bit LoRa with Murata and their latest modules and their emerging trends. So my name is Thorsten Killinger. I'm Corporate Product Manager at Rutronik in the wireless department. And here with me I have Mark Porter, Business Development Manager from Murata, who will speak about the topic in general. The practicalities, so we have about 1 hour of time. So if you have any questions within, just put them into the Q&A session on the right side or on the top, to be honest. And the presentation will be recorded and will be published afterwards. You will also receive the slides from our presentation today. And with that, Mark, welcome. I don't have any information left, so I will just hand over to you and feel free to present your stuff. Thank you.
Right, thanks very much, Thorsten. Good morning, everybody. As Thorsten said, my name is Mark Porter. I am working in Murata Europe in the business development group. Today, I'm going to talk about the LoRa technology. So I'll talk very briefly about myself. We'll talk about what is LoRa, some emerging trends for the technology, a very brief overview of our product range, touch on some planned future product releases, highlight why modules are generally a good approach, a useful approach for wireless technologies in your product developments, and then quick summary, and then we'll open the floor for some questions. So starting with myself, I've worked in the electronic component industry for more than 30 years, and from the photograph it definitely looks like it. I'm working currently, my role in Murata Europe is the distribution channel, specializing in the wireless connectivity modules, and I've been doing that role for the last 8 years. Interesting work for us, the emerging technologies, new technologies coming online constantly. And I'm based in the UK. My primary focus is the short range technologies, and here we'll focus particularly on the long range. So enough about me. Let's talk about the products. So as a component company, Murata is particularly well known for multi-layer ceramic capacitor technology and other related ceramic components. But we also have a significant portfolio for wireless connectivity technologies, and we are involved in a wide range. The long-range technologies, like it says on the tin, these are generally wireless technologies which can transmit data for significant distances, usually kilometers or tens of kilometers. LoRa is the focus for today. That's a low power, long range technology, historically using the sub-gigahertz ISM bands for the communication frequencies. And cellular IoT is a low power wireless technology. It's based on the same cellular technology as in your mobile phone, but the data rates for cellular IoT are severely, severely limited in comparison. We're also involved in short-range technologies. So we have products for Bluetooth Low Energy, which is low power, generally low data rate, based on the ISM 2.4 gigahertz band, the global ISM band. Everybody's familiar with Bluetooth. It's in your smartphone, your smartwatch, your laptop, your car. Wi-Fi Again, generally, historically using 2.4 gigahertz, now in 5 gigahertz and 6 gigahertz, much higher data rates, and again using these global ISM bands. And ultra wideband, which is the latest technology offering from our side, high frequency wide bandwidth signals, generally used for ranging, but also supporting data communications. So LoRa, what is it? Well, LoRa is a low power wide area network technology. It's operating in the ISM bands, those industrial, scientific, and medical bands, which are unlicensed. So generally, Europe, North America, and Asia Pacific are using roughly 850 to 930 megahertz frequency bands. China has adopted the band at 470 megahertz. And in Europe, you can also use the ISM band at 433 megahertz. It can also be used, LoRa now can also be used at 2.4 gigahertz, which would support slightly higher data rates compared to the sub-gigahertz band, but at the cost of range. It's based on a chirped spread spectrum modulation technique. So this is quite similar to radar. The technology's been around a long time and was brought to the market in terms of the LoRa functionality by Semtech. The modulation transmission is quite robust against interference and has a extremely good capability for being received across long distances. So you can see in the table on the right side comparing LoRa with the other common long-range wide area network technologies, narrowband IoT and LTE-M or Cat-M. So LoRa is supporting, potentially up to 15 kilometers in a rural area. It's ideal for transmitting small amounts of data with relatively low bit rates. You can transmit much further than you can with other common technologies like the short-range technologies, Wi-Fi, Bluetooth, or even Zigbee. This tends to make the technology well suited for use with sensors and actuators that can be operated in low power mode, so a kind of fit and forget type of approach. On top of the basic LoRa protocol, LoRaWAN is the media access control layer, the MAC layer, and that's the protocol built on top of that LoRa modulation, the chirped spread spectrum. It's a software layer which defines how the devices use the LoRa hardware, for example, when they transmit, message format, joining the network, etc., etc. LoRa itself, the ecosystem is very large in terms of device makers, companies that are producing the infrastructure, the LoRa gateways, antennas, etc. The big benefit for LoRa potentially in things like these sensor end nodes is the ability to put the device into low power or sleep mode, extending the battery life of a wireless sensor, allowing you to adopt that sort of fit and forget approach. There's also security in the network. There is encryption between the end device and the application server, as well as the end device and the network server. And the LoRa Alliance is driving the standardization. So it's a non-profit organization promoting LoRa technology and improving the capabilities and the standards to make the solution as flexible as possible. LoRa also supports geolocation. It's not high accuracy. You're probably talking in the order of 100 meters plus minus, as opposed to, a few meters with something like GNSS, but it does allow for basic geolocation. And last but not least, the technology can be supported on public networks. So operators in some countries are providing networks in the same way as the cellular mobile network operators, but it is also eminently suitable for use with private networks. A LoRa gateway for indoor use can be purchased from a few tens of euros and support a network configuration with backhaul to the cloud. Looking at the features for the LoRa technology, it does support the key requirements, as the name suggests, is the long range. This will support potentially distances in the order of 10 kilometers in a rural area, perhaps restricted in a built-up area, an urban area, perhaps 3 kilometers due to reflections, etc. We did work with a project where a partner of ours put LoRa up onto a weather balloon and up into high altitude. In that particular instance, I think there was a signal was picked up over 700 kilometers away. So generally, the limiting factors is probably line of sight. It's a low power technology, so long battery life. You can put as I said, you can put the devices into low power mode, and potentially something like a coin cell battery or a AA, AAA battery could give up to something like 10 years battery life. Clearly depends on how much data you want to send and how often, but that's a typical number that's bandied about for the LoRa technology. The network potentially has the capability for very high capacity. LoRaWAN network servers can handle millions of messages, and thousands of gateways can easily be supported. It's a relatively low-cost technology. It does require infrastructure, but as I mentioned earlier, that something like an indoor gateway is very low cost. The cost of building an end node is also relatively low, and the infrastructure, particularly the software side of things, is generally open source software. And the technology is capable of supporting firmware updates over the air, so it's possible to update devices in the field without needing to physically send somebody to reprogram. That's a big benefit of the LoRa technology. Again, coming back to that sort of fit and forget sensor node deployment. As I said earlier, geolocation is possible. It's not highly accurate, but it does allow for reasonable triangulation through the network. Some of the newer chipsets that are available now are supporting GNSS scanning, which will increase the accuracy to a few tens of meters. And for the general LoRa geolocation through triangulation on the network, that doesn't have any impact on battery life. It is a technology for low data rates. It's not something that you would use for streaming video or for sending large data files. It's obviously ideal, however, for sending small packets of data, long distances, and throughput is up to something like 50k BPS. And as I mentioned, security, end-to-end AES-128 encryption in the network for both protection on the applications level and the overall network level. The applications for LoRa, we introduced products back in 2016, and we've seen hundreds, if not thousands, of different use cases or applications for LoRa itself. Here's some of the more interesting ones that have come up, but clearly this is not everything. Give you some feel in the environmental area. Monitoring of weather conditions or perhaps air quality. Sensors can be deployed anywhere within the coverage of 15 kilometers. Seeing interest in wildlife monitoring, particularly for sort of animals who are threatened in terms of extinction, or where poaching of the example here, I guess the rhinoceros, you can add LoRa tags to the actual animals and track that to prevent poaching. Agricultural sensors for monitoring of live crop monitoring in real time, relatively speaking, soil sensors, moisture, etc., allowing for higher yields of the crops. Livestock tracking, very similar to the wildlife monitoring, but the livestock tracking is becoming a very big industry, for a focus for us in terms of the LoRa technology. Generally, a large application area or use cases with cattle, so monitoring the location, the physical, excuse me, health conditions, and when the cattle come into their breeding season, all of these things can be monitored and data collected on the cloud. In a sort of urban environment, smart buildings, smart lighting, street lighting, for example, the street lighting is a very useful, a good application for LoRa because of the long range. Clearly, no need necessarily for the low power. And car parking, we're seeing a lot more customers working with the LoRa for car park sensors for detecting whether a parking bay is occupied or empty. A lot of people are using online apps to find parking spaces, for example. Asset management, location tracking of things like shipping containers, even equipment, and the support of LoRa potentially with non-terrestrial networks or satellite networks will also help to expand the utilization of LoRa in that technology area. Health and safety, measuring crowd management, for example, detecting the flow of people through areas like sports venues or concert venues, etc. Additionally, things like utility monitoring, particularly water and gas, are eminently suitable for LoRa. It's a cheaper technology than cellular, and perhaps data doesn't need to be sent on a very regular basis for those types of applications. Solar tracking of monitoring of PV panels and optimizing their angle to the sun is another use case we've seen. And potentially, as we said about the geolocation, LoRa could be used here for the shared transport, things like rented bicycle or scooters seen in cities. Looking at the latest trends, the 2.4 gigahertz band. Currently, everybody's familiar with the 2.4 gig band. It's used for Wi-Fi. It's used for Bluetooth. It's an ISM band, so it's unlicensed. It's open for use within the standards that are deployed locally, regionally, in terms of interference, etc. The benefit of the 2.4 gig band, it's the same frequency band across the whole globe. When we talked about the other ISM bands, they tend to be regional, with 868 for Europe and 915 for the US, for example. So this would make operating on the 2.4 gig band would make more potential for a single device covering the whole globe. It does get shorter range as a result of using the higher frequency. The laws of physics apply, but should still give something like 2 kilometers with clear line of sight, and will support a higher data rate than the sub-gigahertz bands. The modulation for LoRa is also very good at preventing or tackling interference from other devices in the same spectrum. So this should allow for Bluetooth and Wi-Fi not to interfere too much with the LoRa signal, that chirped spread spectrum modulation. And currently, gateways are available off the shelf for both indoor and outdoor applications. So whilst it may not be a strong technology today, it's readily available. The 2.1 GHz Satellite S-band is also now being supported for use with the LoRa protocol, which will allow satellite connectivity extending support beyond the current infrastructure coverage. So it will allow use of LoRa outside of popular areas and moving out into very remote areas where the network, public or private, is not set up. It's not available everywhere. It's still in development in terms of the technology here and partners, but it will extend the range of that LoRa capability. So looking at something like that, livestock tracking, obviously you can have some infrastructure covering a significant area, but you will be able to use the non-terrestrial or satellite service to cover the peripherals. The LoRaWAN SATCOM approach is basically can be unlicensed ISM bands with low Earth orbit satellites. We're partnered with Lacuna Space, looking at that area, and for the 2.1 GHz S-band non-terrestrial support. These are licensed bands, generally geostationary Earth orbit, and we're working with partners like EchoStar to develop this support going forward. And excuse me, looking now at the products. This is our lineup of the technology. So we first introduced an OpenMCU device with our ABZ module, the product in the top left corner of the slide, back in 2016, based on Semtech's RF chipset, the SX1276, and the STM L0 MCU. Apologies. This is available in both an OpenMCU and a modem firmware solution, giving customers the high level of flexibility and speed to market depending on the use case and application. The majority of the business that we've seen in Europe's been with the OpenMCU version, where you can develop the application in that STM32Cube environment for the microcontroller and flash that into the module memory on the OpenMCU device. There's 192K flash on that MCU. The middle part in the top row, the 1NM module, is basically the pin-to-pin compatible version developed for the China market using that 470 megahertz band. We've seen some customers deploying in Europe using 433. There is some slight RF performance degradation because the front end is optimized for 470, but it still supports the 433 band. And then the top right corner is our current standard second generation product, again based on a Semtech radio chip plus ST Micro's MCU, this time based on the 1262 chip. So this is a smaller, lower cost solution for LoRa or LoRaWAN use. And again, we have both the OpenMCU architecture and modem version with Murata developed modem firmware. Again, if you want to develop an application, you can do that using the STM32Cube environment. And we provide a patch file to support the one SGA module specifically in that release. Across the bottom, we've released some new products, again, based on obviously the Semtech radio chips. Two of the parts, the one WL 2DT, are based on the LR1110 chip, and the latest part on the bottom right corner, the 2GT module, which is based on the 1121 chip. All the modules have supported evaluation kits. You can work with them and the related development tools to develop your own unique, specific application for your use case. Or you can, if you prefer, you can work with an existing host running the application and using the benefit of taking advantage of the pre-flashed modem firmware for LoRa WAN use, or LoRa WAN only. Generally, that's on AT commands over UART. We'll talk about some differences for the 2GT module a bit later on. And to help with access to all of the documentation and firmware, we have a My Murata support site, which is accessed through a code provided with the related module eval kits. So to go into a little bit more detail, looking at the 1SJ module, it's our smallest module today, probably the smallest on the market with an integrated microcontroller. The L0 microcontroller inside, like the ABZ module, has flash memory. That's 192K, which should be more than enough for most LoRa applications. Typically, the sort of LoRa stack is something like 40, 50K. The module can be considered a black box, and the internal matching, switches, TCXOs, crystals, and general components are all included inside the module. Standard interfaces out from the microcontroller to sensors and a 50 ohm antenna port. Typically, those interfaces for the host, if required, would be UART, SPI, or I2C. The module package is a resin mold technology with an LGA footprint, giving you the smallest PCB real estate for the physical size. So this is a 80 square millimeter device. We've done regulatory certification with a reference antenna for North America, Japan, and then the device is compliant for European standards. And this product here could become the heart of a LoRa sensor end node. As a modem, we have developed some firmware to support customers who would like to, perhaps they already have a fairly powerful host in their product, don't want to change the basic architecture, but want to add LoRa as a communication add-on. So here the device is pre-flashed with our firmware supporting LoRa WAN, and communication is by AT commands over the UART interface. The latest version of our firmware in the 1SJ-977 version is supporting the LoRa 1.0.4 standard, and is also capable of supporting sub-gigahertz satellite communication. Looking at the 1WL module, we introduced this at the beginning of this year. It's a highly integrated solution for geolocation applications. The core of the module in terms of the radio is the LR1110 chipset from Semtech. And this time we've also integrated the STMicro Bluetooth Low Energy Wireless MCU to support both the BLE functions and radio protocol, as well as memory and host functionality. There's an option to take the part with MediaTek's MT3333 hardware GNSS chip. So that would give you accurate, consistent location data in real time managed in the module. And there is a variant where the package is the same, but this time the GNSS chip is not fitted and GNSS would only be supported for a GNSS scanning. So physically, this is a large device, but as you can see, high level of integration, RF front ends, antenna ports for three functionalities, and 512K memory in flash available for the application. The GNSS scanning on the LR1110 supports both GPS and Beidou constellations, and then you get a further range of constellations supported if you take the variant using the GNSS hardware chip. At the minute, it looks like the accuracy between GNSS hardware and GNSS scanning functions are fairly similar, around about 10 meters. The support for interpretation of the GNSS data for the scanning function is managed on the cloud, whereas with the GNSS hardware chip, as I mentioned, that would be completed on the module device. And this is a metal shield construction on an FR4 substrate, and as I said, using the same physical package with and without the hardware chip. The 2DT module, also based on the 1110 chipset from Semtech, so again a strong candidate for use in geolocation applications. This is the LoRa transceiver only, so we don't include the MCU function in this particular module compared to the ABZ1SJ. Still all of the internal front end requirements, switching, etc., TCXO crystals, so again a black box approach. 50 ohm antenna ports for the sub-gigahertz GNSS scan and Wi-Fi passive scanning. And this will also support the sub-gigahertz satellite communications based on that LR1110 functionality. Small module package, external host is required and communication over the standard SPI interface. And finally, on the product lineup, the 2GT module, our latest product release with the LoRa technology. Again, a transceiver only, same approach as the 2DT, and also the same physical package, that roughly 10 by 8.7 millimeter. The module doesn't include that internal MCU function, so there's flexibility on that external host selection. We have some standard MCU supported with porting. Potentially, we can also look at expanding the porting support for other MCUs, particularly if there's a suitable volume demand behind that choice. We are looking at a modem variant. We'll talk about that on the next slide. And with the 1121 chip from Semtech here, it includes the sub-gigahertz support for LoRa, but also the 2.4 gigahertz support for LoRa and the 2.1 gigahertz Satellite S-band. Currently, the S-band support is TX function only and would require an external PA. Generally, this is a cost optimized solution without, for the LoRa technology. So this is the most price aggressive solution we have. Then looking at the modem approach with the 2GT module, so we're calling this modem E. It's a slightly different setup and architecture. So here we've partnered with Semtech to develop the modem firmware for the module. This will actually be flashed into the chip inside the module, so it's supporting the LoRaWAN stack directly. And this time, communication is API commands over the SPI interface, similar to the 1SJ modem with AT commands over UART. The final version of this modem firmware is being released now, and can be provided to customers for testing. Having a modem solution here means that the microcontroller selection is even more flexible than with the standard 2GT module. It's potentially possible to use very low cost, low memory microcontrollers, making this a very cost effective LoRa solution. With the modem functionality, potentially a quicker time to market and less work required in terms of application development, because you're running standard APIs. And like other modules, we're covering the regulatory certification. Also, the LoRaWAN certification is planned for this product. And our roadmap. A lot of products came out during 2024, and with any luck, if the schedule is kept to, we should be releasing the modem E version of the 2GT module by the end of this year, probably around about December time. And that takes us on to the benefits of using module technologies. So, like other technologies, other wireless connectivity technologies that we have and other companies are offering, it's relatively straightforward to leverage a simplified RF design, which reduces the development time for the product. You can minimize the design resources for the wireless aspect. And as a regulatory certified product, the final product certification is simplified. The timescales of certification are reduced and the risks minimized. We share the reference antenna data to make this as easy as possible for customer use. As a Japanese company, we are offering small sizes. We're probably offering some of the smallest modules on the market. And many of the components in the bill of materials are also very small case size packages and coming out of our own standard product portfolios. And as we mentioned, the radio standards, pre-certified module particularly for the North America market, can save a lot of time. It certainly reduces the risk, and data is available on those support sites to help you work with our product on the product certification aspect. In addition, as a module maker, we can pass on some of the slightly less tangible benefits. We have partnerships with these best-in-class IC makers. We're testing in our production, so any issues about yield are absorbed on our side. Potentially, functional testing could be done on the module in the product rather than a full RF test. And obviously, with a single component, the bill of materials and the sourcing aspect should also be simplified. In summary, Murata, we're covering a wide range of these wireless connectivity technologies. Gives you an opportunity to work with the technology that fits best, or a combination of technologies. Modules from any module maker will speed up the development of the finished product, reduce the risk, minimize the risk for working with wireless technologies. When we talked about the application areas, a lot of companies in some of these application areas startups are running from an idea basis, and particularly the electronics hardware and particularly the radio aspect is not their core strength. So modules are a big enabler in that respect. We're working with those best-in-class IC partners for the best solutions in terms of new technologies and performance and reliability of service, etc. The products we make are small size, high quality, and generally cost effective. We've got a strong European-based team supporting local and regional activity, including field application engineers and product specialists. And then we have access to development teams in other parts of the world who are developing the physical parts. The LoRa technology offerings that we've talked about today, many can be supported with the open MCU architecture, or if preferred, we can provide pre-flashed modem firmware. Technologies supporting low data transmission with long range and low power consumption. It's still a very strong technology offering. It's still a lot of interest in LoRa. We can support the products through most of our distribution channel, giving you easy access to samples, evaluation kits, and in inventory. We are developing new products constantly. We're always looking at the latest technology, offering the best feature sets, and in the case of LoRa, that's generally coming through the Semtech radio chip. And these modules generally make the implementation in your product as easy as possible, as quick as possible, and without too many pain points. So I guess at this point we can open to questions.
All right, thank you, Mark, for the presentation. It was very interesting. Maybe you can stop sharing your screen, and then we will jump over to the questions, as there's already a few. So I would start with the first one. It's not related to LoRa, it's more related to ultra-wideband, but I think you can also answer it. In ultra-wideband, have you tested the WSN applications despite of using it in positioning? Does it work, or is it not focused on solving this sensor network requirements? Can you answer this?
Honestly, off the top of my head, I don't know the answer, to be honest,
good.
Torsten. Yeah.
Then we will take it offline, and we will reach out to you answering your question. Mark, I will provide it to you, and then we might be able to give it further. So coming now to LoRa. So can you elaborate on the specific applications where 2.4 GHz LoRa offers a distinct advantage over traditional frequency bands?
So looking at that 2.4 gigahertz, probably the single biggest benefit for use of the 2.4 gig band is the fact that a single device, a single SKU could be offered for global coverage. The 2.4 gig band has no regional restrictions. So compared to the sub-gigahertz, where 868 is allowed in Europe, but not in the US. 915 is suitable for the US and not Europe. It does allow you to develop a product giving true global availability. That probably makes it best suited for applications such as logistics or asset tracking, where LoRa is giving you the best coverage. It will also give them, as we mentioned, it will also give sort of higher data rates, which may also be less affected by some of the duty cycle restrictions which apply on the sub-gigahertz band. And it will also perhaps be best where a slightly more real-time data transmission is required. So maybe in some sort of industrial monitoring, that type of application, where you can transmit higher volumes of messages in a given time period.
Okay, thank you. Next one, how does the 2.1 GHz Satellite S-band enhance the reach of LoRa networks in areas where terrestrial networks are not available?
Okay, so the satellite or the NTN capability for LoRa is still quite new. but that 2.1 gigahertz band will allow expansion of networks using satellite technologies to cover remote or areas where it doesn't make practical sense to deploy a physical network on the ground. It's not worldwide coverage today. It is limited to that geostationary Earth orbit satellite functionality, so that there are some restrictions at the moment in terms of that approach, but it will essentially extend into, beyond the terrestrial network. It will allow LoRa coverage beyond that. Power consumption should still be good, and you're basically enabling applications like, as we said, the livestock monitoring. So beyond the limits of the physical network coverage, the S-band satellite coverage would open up whole new geographies for support of the LoRa technology.
Okay, thank you. Again, one question in 2.1 gigahertz. When do you think 2.1 gigahertz satellite demo will be available? Which Murata module will be best suited, and which antenna? With which antenna?
Right. So we've already done some work with the 2.1 gigahertz approach. So as I mentioned, we've done some technology with we've done some work with EchoStar. We can provide you with some inputs on the antenna for the 2.1 gigahertz band. We've got some reference design there. The expectation for 2.1 gigahertz is, whilst the module technology is capable, so that would be the 2.1. That would be the 2GT module with the support for the S-band. That's based on the 1121 chip. So whilst the support is there, it looks as though physical use will require an external PA. So we're working on developing a reference design or application circuit and suitable PA to support that. So we can we're working today that there is some activity with the 2.1 gig S-band support already, so we'd be happy to share that with anybody who's has a specific interest.
Okay, thank you. Next one would be, how do Murata's latest LoRa modules, such as the Type 2GT or and the Type 1SJ, offer unique benefits when compared to previous generations?
So if we look at the 1SJ module, benefits for the usage, physical size, the chip, the 1262 chip has some improved receiver sensitivity, and also some power consumption benefits over the earlier generation, the ABZ module with the 1276. Looking at the 2GT module, you've got support there for flexible external microcontroller use, potentially the modem functionality with that modem E configuration. You've got access with the 1121 chip to the 2.4 gigahertz and the 2.1 S-band support. And again, in small package, I know it's not necessarily what everybody wants, but with the small package, you've got the ability to develop smaller sensor nodes and/or add additional functionality into your product where the wireless connectivity takes up less space.
Okay, thank you. So coming now to the last question I currently can see, with GNSS scanning, how big is the scanning data to send off the cloud? Will this saturate the duty cycle at 868 megahertz and avoid using the rest of the on-air time of customer usage?
Now, that's a really good question, and I'd like to say I know the answer, but I will have to do some research there. It's a very, very good, question, and obviously quite specific. But we'll have a look at that. I can't regrettably answer from the top of my head.
All right. No, then we will take this offline and answer this question afterwards. So then I don't see any further questions. So I will just share one time my screen in order to provide you some further informations. So if you have any questions or if you want to have any information, you can always visit our rutronik.com website if you want to order some samples or in general have a look of what is Rutronik offering. We have our web shop, the Rutronik 24. And if you are interested in some kind of technical posts and something like this, there's also the Rutronik Tech website. We also provide newsletters and are visible on social media. Once again, here are my contact details. So Thorsten Killinger, always reachable, I would say. And if you don't want to reach out to me directly, you can always go to our contact formula on our webpage, where we then come back to you and answer your request at best. And last but not least, today we had the 4th webinar of our 7 webinars this week. So tomorrow, later this day, we will have Kyocera AVX talking about antenna systems of ultra-wideband and LPWAN. Tomorrow then is the last day where we have Edge Impulse talking about machine learning with Nordic Semiconductor. And later tomorrow we will also have Yageo also talking about antenna solutions for LoRa and ultra-wideband. So that would mark the end of the 3rd week, and in not only two weeks we will have our last week with Bluetooth, where we talk about Bluetooth 6, channel sounding, and many more information. So keep it in mind, and the first, let's say, informations will be published somewhere in this day, so keep an eye on it. With this, I thank you, Mark, for your presentation, and I will say have a good day. Thank you.